Next problem in type 2, reframe not required, and we are doing the shift the origin. The following data represent the number of units of production per day turned out by 4 randomly chosen operators using 3 milling machines, right? So M1, M2, M3 machines, operators 1, 2, 3, 4, right? Test perform analysis of variance and test hypothesis. A, that the machines are not significantly different, that the operators are not significantly different at 5% level. Total number of items n is equal to 12, and the number of columns, that is machines 3, number of operators row r is equal to 4. Defining hypothesis H0, there is no significant difference between machines and there is no significant difference between operators. So two hypotheses, null hypothesis, then alternate hypothesis. There is significant difference between machines and there is significant difference between operators. Now we are going to shift the origin to 150. So subtract each and every number. 150 is subtracted from each and every number in the above data, that is given data, right? So 150. So first operator 1, 150 minus 150, 151 minus 150, 156 minus 150, etc., etc. Then last fourth operator 159 minus 150. So you will get 0, 1, 6, 3, 9, 5, 9, 4, 3, 4, 2, 9. So new data, we are going to use this data to calculating ANOVA, right? So next calculation for ANOVA, operators A, B, C, D, machines M1, M2, M3. Operators you can write it as 1, 2, 3, 4 also, no problem. So the data, I am writing the data 0, 1, 6 minus 3, 9, 5 minus 9 minus 4, 3, 4, 2, 9. Then first row total. So first row total 0 plus 1 plus 6 7 minus 3 plus 9 plus 5 11 minus 9 minus 4 plus 3 minus 10 4 plus 2 plus 9 15. Sum of the similarly column total. First column total 0 minus 3 minus 9 plus 4 minus 8 1 plus 9 minus 4 2 plus 2, that is 8. Second total, second column total. Then third column total 6 plus 5 plus 3 plus 9 23. Then grand total. So either you can add column total or row total, all the row total and equal to the all the column total, right? So 7 plus 11 minus 10 plus 15 or minus 8 plus 8 plus 23. So total is 23. That is the grand total G. Next we have to find Ri square by Ci. So squaring each R divided by Ri square, squaring each Ri and divided by corresponding C, right? Here C is 3 for all the 4 operator. C1, C2, C3, C4 all are equal to 3, right? So first 7 square by 3, 16.33. Then 11 square by 3, 40.33. Minus 10 square by 3, 33.33. 15 square by 3, 75. Then sum of Ri square by Ci, that is equal to 164.99. Similarly for column Cj square by Rj, right? Here R all are equal. So R1, R2, R3, R4 all are equal to 4, right? So first C1 square by R1 minus 8 square by 4 16, 8 square by 4 16, 23 square by 4 132.25. Sum of Cj square by Rj 164.25. Then you have to find the row sum of squares of each number. First row 0 square plus 1 square plus 6 square 37. Next minus 3 square plus 9 square plus 5 square. Second row 115. Then third row, minus 9 square minus 4 square plus 3 square, 106. 4 square plus 2 square plus 9 square, 101. Next, similarly for the column squares, 0 square minus 3 square minus 9 square plus 4 square, first column, 106. Second one, 1 square plus 9 square minus 4 square plus 2 square, 102. Then 6 square plus 5 square plus 3 square plus 9 square, 151. Then sum of squares. So sum of xij square, right? So that is equal to, add either this row side or column side, both should be equal. 106 plus 102 plus 151 column side, or row side 37 plus 115 plus 106 plus 101. So you will get 359. Right. Next, correction factor CF is equal to G square by N. So 23 square by 12, that is equal to 44.08. Next, total sum of square TSS. Formula SS minus G square by N. So you will get 314.92. So you take the details from the previous table. Row sum of squares, right? It is between the operators, not varieties, between the operators, RSS. Sigma Ri square by Ci minus Cf. 164.99 minus 44.08, 120.91. Next, column sum of squares, blocks between the machines, CSS. Summation Cj square by Rj minus Cf, 164.25 minus 44.08, 120.17. Next, error sum of square or residual, TSS minus CSS plus RSS, that is equal to 314.92 minus 361.25, 73.84. Next, prepare the ANOVA table, source of variation, column, row, error. Sum of squares, CSS 120.17, right? You have calculated above, right? Then RSS 120.91, ESS 73.84. Next, degrees of freedom, CSS C minus 1, right, for column. V1 equal to C minus 1, 4 minus 1, 3. Then for row, V2 is equal to R minus 1, 3 minus 1, that is equal to 2. Then V3 is equal to R minus 1 into C minus 1, 2 into 3, 6. Next, you have to find the mean sum of square. So mean sum of squares of column, CSS by V1. So you will get 40.06. Then row sum of square, mean row sum of square, RSS by V2. So you will get 60.46. Then error, mean error sum of square, ESS by V3. So 12.31. Next, F ratio. So first column, FC. So MCSS by MESS, because MCSS is more than MESS. 40.06 by 12.31, 3.25. Then row ratio, FR. So here MRSS is more than MESS. So MRSS by MESS. So you will get 4.91. Next, conclusion for machines. So degrees of freedom V1, V3, right? 3, 6, because MCSS is greater than MESS. When you are writing the degrees of freedom, so you have to write the degrees of freedom of the greatest one, that is the numerator one, right? Then denominator 3, 6, like that. So tabulated value 3, 6, right? 5% level of significance 4.76. So compare FC and FT. So FC 3.25 is less than FT, that is 4.76. Therefore, H0 is accepted. Null hypothesis is accepted. Next, for the operators. So degrees of freedom V2, V3, 2, 6. So now the tabulated value for 2, 6 at 5% level, FT is equal to 5.14. So compare FR and FT. So FR is less than FT, therefore null hypothesis 2 is also accepted. Thanks.